Hello, my name is Chris Nash and I'm from the Creative Technologies Lab at UWE Bristol. This video presents technologies and techniques supporting crowd-driven music, the generation and manipulation of music based on real-time input from a chaotic crowd scene, such as people in a public space. This project was originally developed to support a public installation for BBC Music Day 2018, in collaboration with the BBC, Bristol Templemead Station, and Bristol's recovery choir, Rising Voices. The event and associated artwork serve to demonstrate several challenges and solutions in the creation of crowd-driven music designed for a public audience. The presented system works in real time, using machine vision to capture and analyze a live video feed of a given space, and deliver data about detected objects to Manhattan, an end-user programming platform for music, originally introduced at NINE 2014. Rather than a bespoke solution for a single performance, the wider goal of the project was to develop an accessible platform for future artists to explore mappings of crowd activity to musical structure, notably in this year's workshop. To this end, the project established 4 design principles to meet the diverse needs of different artists, audiences, and spaces: agency, accessibility, aesthetic, and adaptability. In agency, the crowd should be able to appreciate their influence on the music, either as individuals or part of a group. Ideal mappings should be robust enough to give individuals a sense of control even during busy and crowded periods. The paper specifically introduces a clustering and mapping technique dubbed chaotic counterpoint, developed to balance the musical influence of crowd members and groups during periods of relative calm and chaos, while also reducing the entropy of busy crowds to facilitate coherent musical mappings. Here, the crowd is sorted into 5 clusters by iteratively merging the 2 closest individuals or groups based on their lateral position in the frame. The new merged group is formed of the weighted average of their members' individual positions and some of their weights, their visual footprint in the frame. Vertical position was also later used to factor in proximity to the camera and amplify the effect of people actively engaging with the system. Each cluster maps to a voice in a 5-part polyphony, using lateral position to set the initial pitch and weight to set note dynamic. The pitch is then harmonically quantized based on the set of permissible pitches given the current musical context, specified by the composer and code. To achieve a consonant tonal aesthetic suitable for the general public, Parrott's tintinnably method was adapted to select pitches from sets based on major or minor triads in the wider context of a standard 1-4-5 progression. In this mapping, while the composer controls the underlying harmony, the voicing of the chords are left to the public, with clustering allowing individuals and groups to still hear their influence as changes in pitch and dynamic, as shown in this example, which begins with 2 clusters, left and right in the frame, yielding a low note and a slightly softer high note. A new person enters close in right, and is absorbed into the second cluster, increasing its pitch and dynamic. But as the person moves left, they pull this emphasized pitch lower, which continues until they close on the other cluster, whereupon they switch membership. Although both pitches increase, the dynamic emphasis shifts from high note to low note, preserving the continuity of a descending pitch. The person continues to exert influence over their new group, until their departure resets the scene and music to its initial configuration. The principle of accessibility requires that the music generated should have a broad appeal to the audience. Both interactive and generative sonic arts often engender experimental or abstract musical aesthetics, appreciated most by knowledgeable audiences and enthusiasts. However, to resonate with the broadest audience, BBC Music Day targets mainstream aesthetics popular with the general public. In moving away from abstract sound art, sophisticated mappings are required to meaningfully manipulate complex formal systems of pitch, harmony, tonality, time, and structure in a way that is not only musically coherent, but interesting to this audience. And while a lay audience may have little explicit knowledge of music theory, they are experienced listeners and discerning judges of quality, or lack thereof. The principle aesthetic requires that the technology should support a coherent musical voice, idiomatic of the artist. Artworks, as forms of expression, convey the ideas and aesthetics of the artist, who values their control, ownership, and authorship of the work. In surrendering agency to a crowd, an example of what Umberto Eco called an open work, the artist, at least in part, surrenders this. Moreover, in technologies for crowd-driven music, the work is not only a synthesis of the input from the crowd and the artist, but heavily shaped by the affordances of the technology, such as the creative possibilities or limitations engendered in the object detection algorithm, or provisions for defining mappings to music. To gain control of this, the composer must become a coder, which in this project is facilitated through the use of the Manhattan platform, which couples a pattern-based music sequencer with an accessible formula-based spreadsheet-style model of programming, seeking to bridge editing and coding practices, not to mention communities and aesthetics, with live scripting support for input handling and sophisticated generative applications. Manhattan supports a low-threshold, high-ceiling approach to learning and using code in music, allowing composers to flexibly combine conventional music editing with procedural elements, the versatility of which notably also facilitates the exploration of crowd-driven music in the context of mainstream musical styles. Finally, adaptability states that the piece should vary over time, not only responding to context, but also avoiding repetitiveness. Music is a synthesis of patterns and repetitions, but critically also change and process. While randomization can add variation, a noisy crowd provides a source of chaos, within which there may be order, emergent behavioral patterns which can be used to lend structure to the music. Installations based on crowd-driven music are envisaged as semi-permanent fixtures occupying a space, and must therefore be sensitive to that space. For example, a quiet period might engender soft music, a busy period faster and more hectic, though it may be inappropriate to add tension to an already stressful environment. The choice of space is critical. A scene with a dynamic and changing crowd disposition has inherently more variation than one that is always quiet, always busy, or otherwise lacking a diverse stimulus for the music. For BBC Music Day, Bristol's main railway platform offered periods ranging from quiet and deserted to hectic and packed, and a variety of agents and activities including waiting passengers, moving trains, those running for trains, and both individuals and groups. Moreover, when agents become aware of the process, the system forms a closed feedback loop, where subjects cease to be passive listeners and actively engage with the generative process, stopping, listening to the music, and then experimenting with movements to audition their effect. Many also tried gaming the system, probing it in an attempt to produce false detections or push the limits of the musical mappings. Shooting representative footage of the space in advance was an invaluable tool in preparing a nuanced and robust musical performance. Two pieces were developed for BBC Music Day, respectively in classical and trip-hop styles, using different mapping techniques. Mirroring themes in performances elsewhere in the country, both pieces included choral elements and ties to the local community. The first piece uses the chaotic counterpoint technique to generate music in a minimalist style, arranged for piano and choir, using concatenative synthesis to sing the boroughs of Bristol using the generated harmonies. Every pitch is generated from objects on the platform, with the overall dynamic, instrumentation and tempo gradually varying with the ebb and flow of activity. Listen as a busy train arrives at an otherwise quiet platform. The second piece uses a simpler application of chaotic counterpoint, performed using multi-samples from Bristol Drugs Project's Rising Voices Choir, providing not only the choral notes, but much of the percussion sounds, as part of an homage to Bristol-based trip-hop artists Massive Attack. This piece generally uses simpler mappings designed to make the effects of different objects more salient to the public audience. For example, a synth bass part plays only in the presence of a suitcase, such that if a traveller walks off with the suitcase, they walk off with the bass. Additional instrumentation, especially drum programming, is added or removed depending on how busy the platform is. At quieter moments, the drums depart, and a swept synth pad provides an airier atmosphere. Here is this piece performing the same train arrival. Both performances were entirely run on a single laptop computer, the overall system consisting of a live HD video feed from a wireless IP camera, the footage of which is received using OpenCV and analysed in software using machine learning, specifically YOLO, or You Only Look Once, an optimised object detection process based on convolutional neural networks using the COCO dataset to support real-time detection of up to 9,000 different objects. Analysis is performed using OpenCL on the GPU, freeing the CPU for music and audio processing. And while performance will depend on hardware, detection rates as low as 5 frames per second are enough to support generative music processes, where decisions and changes are typically synchronized with longer musical intervals such as beat, bar, or phrase. Please see the full paper for further details and longer examples from the project. Should you be interested in exploring crowd-driven music, interactive elements of the 9 workshop are accessible inside the Manhattan software, including working examples and sample crowd footage with embedded detection data. please contact the author for live applications, or if you are otherwise interested in the project or Manhattan software. Thanks for listening.